Hi, this is Course Math Insights, the first in its series. This is on the principle of algebraic equations. And we're going to do algebraic equations from a Course Math approach. But first, let's look at the traditional approach. This is what an algebraic equation looks like. Now, can you do this? It looks, I can read it out to you in case you can't read this. This says 3u plus 2 equals 2u plus 4. There, I read it out to you. Did you understand that? In case you didn't understand it, and those of you who've done this in school were wondering, I've done these equations, I know what to do. It's like you move things from left to right and something about signs and, I could do this. I never understood it really, but I could do it. Well, this is for all of you who never really understood it. We're going to dismantle that entire landscape, that messy landscape where you were following certain rules without really understanding what it was all about. We're going to now help you do these very same questions almost mentally. By the time you're through with these 3 videos, you'll be able to do it in your head. You don't even have to write it down. So, what I'm going to do is take you through 3 stages or 3 parts. The first part, we're going to explain to you the principle of an equation and also help you solve them. But we're going to use trial and error strategies to solve them. In the second part, we're going to use the same tubes and peas, but this time we're going to use a very specific strategy to help you arrive at the solution really quickly, and it's going to be a really smart way of doing it. And once you've got the hang of part 2, we go to part 3 where we record everything you did in part 2. We literally record it. Just write it down on a piece of paper with a pencil or a pen, and you have basically the solving of the equation in a very mathematical way, a very formal way, and that's all that it's about. So let's start with what is the principle of an equation. So we have tubes on the left, tubes on the right. They look the same. We have p's on the left, p's on the right. They also look the same. You could say this is a perfect equation. The total number of tubes and p's on the left equals the total number of tubes and p's on the right. Great. You have an equation. But we think of an equation in terms of just p's, not tubes. No tubes, just p's. Okay, so you don't see any p's outside these, but actually, if we start putting p's inside these tubes, these are the containers. They represent p's, if you like. So if we start putting the same number of p's inside each tube, then what do we have? Let's put in 1. Okay, so we've got 4 and 4, 8 on the left, 8 on the right. So they're the same. We can put 2 inside each tube. We'll still have the same number of p's on both sides. 12 and 12. We put in, so the left side and the right side are the same. That's why we call it an equation. The word equation, like equal. So we put in 3 inside each tube. We still have an equation. 16 on the left, 16 on the right. That's what we call an equation. Only we think of an equation not in terms of tubes and p's, but just p's. Think p's. How many p's do we need to put inside the tube so that we get the total number of p's the same on each side? Because the tubes and p's can be different. You can have 3 tubes and 2 tubes on the right side. And you have 2 p's on the left and 4 p's on the right. They don't look the same. But if we think of in terms of putting the same number of p's inside each tube, let's put in 1. We have 5 on the left, 6 on the right. Okay, that doesn't work. Let's try put in the second one. We have 8 on the left, 8 on the right. It works. It works just fine. So that's what we call an equation. How many p's go inside each tube so that we get an equation? Both sides have to be equal. If you put a third one, it won't be the same. If you put a third one inside each tube, we get 11 on the left, 10 on the right. That's not an equation. So no, that's a no, not an equation. We have to put only 2 in each side. So that's an equation. 2 inside each p. So each tube represents a certain number of p's. The total number of p's on the left should be equal to the total number of p's on the right. If you can work out how many p's to put inside each tube, you have an equation. That's it. So let's try this one. How many p's should go inside each tube here? Let's try 1. We've got tubes and p's. 1 inside each would make this 5 on the left, 6 on the right. No, it doesn't work. 5 and 6 doesn't work. They're not the same. Let's put a second one. Okay, we have 8 on the left and 8 on the right. That works. We have an equation. So we've solved this problem. We've solved the problem of how many peas go inside each tube so that we have an equation. Okay. What about this one? This is a big number. This is the big guy. Okay, we put in 1 each and see what happens. We have 4 and 2, 6 on the left, 3 and 5, 8 on the right. Nope. No go. Put in 2. We have 10 on the left, 11 on the right. No. We put in the third one and we have 14 on the left, 14 on the right. That works. There's an equation. So each tube has a fixed quantity that would work for each set of equations, and that's all there is to it. So you can do this with not just with tubes. You can do it with anything. You can do it in your class. You can do it in your school. You can do it at home. Just put in a jar, bottles, dice, buttons, whatever. Just use things, and you use containers, and the answer comes. Work it out. Once you've done that, you can download part 2. Thanks, and have a great day. Bye-bye.